Behind the scenes of every factory, there are lots of electrical panels that make the process work properly. These electrical panels can be distributed throughout the process or located in a special room like control room or electrical room. The electrical structure and architecture of a plant could be the story for another day. But in this video, as you've requested in the comments, I'm going to talk about one of the most important electrical panels, which is the electrical control panel. So stay tuned to the end of this video to get some practical insight into electrical control panels. The number and the size of the panels may strongly vary depending on the type and scale of the control system. For example, the control system is DCS, then we might need up to 4, 5, or more separate control panels. The control system is PLC-based, then one single door or a double door panel could be enough. The first is the enclosure, which houses our internal devices. I'll explain more about the enclosures in a future video. The internal devices should be installed on a thin metal sheet called the mounting frame or back panel. The first piece of component to install on the mounting frame is the DIN rail. DIN rails are some long metal strips with a standard size and some holes in between that we need for mounting the electrical devices on that. In other words, instead of installing each piece of component separately, we can snap and click the components into place easily. So, we cut and install them according to the panel design. The second piece that I'm going to install on the back panel is the wiring duct. You'll see that how wiring ducts will organize and cover the wires within the panel. After we cut and install the ducts inside the panel, let's get into the electrical components of the control panel. First things first, we need electrical power inside the panel. Depending on the electrical system architecture of the plant, in some of the control panels, we have a three-phase power entering into the panel. Yet, in most of the middle to huge size projects, we supply the control panel with only a single-phase power. Now, assume our single-phase power is entering to a two-pole miniature circuit breaker, or MCB. This electric power comes from another panel within the electrical room, like a kind of low-voltage power distribution panel. Either way, the MCBs are a type of protection circuit breaker that are used in the entrance of the panels with different consumptions up to 25 amps. They protect our panel from overload and short-circuit faults. Furthermore, we can connect and disconnect the whole power to the panel manually using this MCB. Now that we have electric power inside, we should distribute it between different devices. First, we need to supply the utilities of the control panel, like the lamp, fan or heater, and socket. Let's consider a separate MCB for each of these devices. The standard way to connect the wires to an MCB is to connect the input wires to the top side and the output wires to the downside connectors. So, I take the power from the main MCB and connect it to the input of the other MCBs. This one is for the socket and the lamp. This one is for the fan. And this is for the control's power supply. To step the power down from single-phase 120 volts to the control voltage, which is 24 volts for example, we need a 24 volts power supply with an appropriate amperage capacity. The next step is to connect the 120 volts to the power supply. Take the 24 volts from its output and distribute it over some terminal blocks. As you may know from our previous videos, by using a terminal block, you can join two wires to each other. To connect all of the terminal blocks of the same purpose, we can use a terminal strip jumper. I should put it in the middle holes of the terminal blocks and fasten its screws. In this way, all of these terminal blocks will have the same voltage of 24 volts. I have planned to dedicate this power supply to the PLC CPU and its input-output modules to even protect them more against any faults that may happen outside of the control panel. Therefore, I should consider a separate power supply with sufficient amperage for feeding the devices at site, such as instrumentation devices. I repeat the same procedure for this power supply, but this time instead of ordinary terminal blocks, I consider some fused terminal blocks to protect the power supply against drawing extra amps by the devices at site. I'll explain that with a practical example in a video about troubleshooting the control panels. Alright, it's time to add the PLC and its input and output cards. Think of the PLC, or Programmable Logic Controller, as the brain of the whole control or automation system. I connect the 24 volts to turn it on. I would connect separate 24 volts from these terminal blocks to each digital input and digital output card to turn them on. Normally, we do not wire the PLC card channels directly to the devices at site, either digital input or digital output cards. It means that if our digital input card has 16 channels, then we should install 16 terminal blocks corresponding to that. It is the same story for the digital output card. You might be wondering when we have more DI or DO cards, we'll be in lack of space for all of the terminal blocks. It is true, of course. If we have a huge number of inputs and outputs in the process, the layout of the panel gets completely different from what you see here. There should be another panel, known as the marshalling panel. In this way, we'll transfer all of these terminal blocks to the marshalling cabinet. In some enclosures, the rear section of the mounting frame can be used as the marshalling part of the panel, so that we can merge the control and marshalling panels and save lots of space in the electrical or control room. Now, let's have a brief overview of how to connect the sensor to our control panel. Take this photoelectric sensor as an example that is installed adjacent to the conveyor and is supposed to recognize the boxes that are passing by on the conveyor. As this sensor requires power to operate, I'll connect the 24 volts to that from the second power supply's terminal box. It should return these 24 volts to the PLC input card in case it senses a box or object in front of that. So I'm going to go ahead and connect a wire from the sensor to its corresponding PLC's input channel. After this sensor informs the PLC about the presence of the box, the PLC should command the next conveyor's three-phase motor to start turning. To do so, we should add a contactor to our control panel. Connect a three-phase power to its input and lay a cable between the contactor and the motor connection box. Actually, when we have three-phase power within our electrical control panel, the arrangement of the panel would be somehow different from what you see here. But let's take it easy and move on for now. As soon as the PLC output card energizes the contactor, it will transfer the three-phase power to the electric motor. You'll also find some relays in the control panel to command the single-phase actuators and control devices at site like solenoid valves. As you'll see in future videos, the electrical panels and devices are scattered throughout the whole plant, and they should be interconnected to each other despite the different communication protocols they might use. So the other category of devices you'll definitely find within any electrical control panel are industrial communication devices, such as Ethernet switches, or some gateway devices such as Profibus PA to Profibus DP couplers. Let's cover the docks and you'll see how the panel looks neat and tidy. I really hope you've enjoyed this video. I deliberately left some of the details for future videos to first touch the basics and dive into the details